Hey guys, I'm Jim, KN4YCD, and you're watching FEP Labs Radio. Thanks for coming. How have we enjoyed the Hamfest so far? A lot of great content yesterday and Friday. Today we still got more coming. All right, let's talk about coax switches. Near and dear to a lot of people's hearts. We have a couple models that we're going to specifically look at today. We're going to tear them apart. We're going to put a meter on them. We're going to put them on a VNA. We're going to do a lot of talking about these things. All right, so there's a few things I want to talk about before we look at our coax switches. There's two basic types. There's manual mechanical switches, and there's electronic switches, which are typically your remote ones. Those are designed for multiple antennas and or multiple radios at the same time. We're going to cover manual switches today. Switches are rated by number of ports they have, typically 2 or 4. The more expensive ones could have 6 or 8. Most hams are going to have a 2-port or a 4-port. The power rating, what that switch can handle in wattage. The two I have, both of them are well over 1,000 watts. I think one's 1,000 and one's 1,500. We'll look at that in a minute. How much isolation the switch gives you in dB. So typically you're looking at 50 plus dB of isolation for most coax switches. And those specs will be listed on the web page when you're looking at the switch, whether you're buying it from HRO or Gigaparts or RNL, it doesn't matter. And then the other thing, of course, is the SWR for that switch and the frequency range for that switch, and that didn't make it onto the slides. And the switch will be rated for a certain SWR up through a certain frequency, and that varies. Typically, the SWR will creep up higher as you get up into the VHF and UHF range. Most ham radio operators are going to use these for HF purposes. And the ones we're looking at today are really designed for HF more than anything, although they are rated up through UHF. Some switches may have additional features. As I mentioned, the remote capability, lightning protection. That's a feature of the Alpha Deltas. They have that little arc plug thing in them that provides lightning protection, and a hard ground. Again, that's a feature that the Alpha Delta has. The little Daiwa didn't have either one of those. It doesn't do lightning or a hard ground. Manual switches generally allow bidirectional operation, one radio in to 2 antennas or 2 radios out to 1 antenna. And that's what we're going to test today. Is it safe to go with 2 radios out to 1 antenna with one of these switches? Electric remote switches typically are not bidirectional because of the electronics in it. It's going to be 1 or more radios out to 1 or more antennas based on what model of antenna switch you buy. The manual ones do not have that restriction typically. Okay, so here are the coax switches that I have to talk about today. I have 2 of them. I've had this one for a while. This is a Daiwa model CS201. It's a 2-port switch. And here's a newer one that I bought recently, and this is an Alpha Delta 4-port switch called a Delta 4. I think it has a fancier model number. Yeah, maybe not. This comes in SO239 and N-type as well, so I bought SO239s. Obviously, both of the switches have heavy, solid metal cases, all metal, all the time. There's a few differences besides the number of ports. This switch is basically a 2-position switch, and whichever way the arrow is aligned is the connection that's in line here with this side of the switch. There is not a center detente, although if you hold it in the center, it'll sit there and it's not connected to either side at this point, but that is not a click position officially, and you could probably, well, it's not that soft, not that easy to nudge. It has screws and a bracket, or not a bracket, a tab to ground it to your shack ground. So let's take a look at the other one, the Alpha Delta. This is a 4-port, same kind of metal frame. This grounds to your shack ground here. So you'd hang this on the wall somewhere and fasten that little silver part that's bare metal. It's been milled out. You'd fasten that to your shack ground. Now the Alpha Delta has a couple things, obviously, that this doesn't. It has a common position. The Daiwa does not have that. This is straight to ground. None of the antennas or none of these connectors are active when it's in the common position. This is our input. So this is typically going to be your radio or your antenna. Whatever your single connector is going to be on the common. And then your other devices will be on one of the separate ports. And then, of course, on the deltas, on the alpha deltas, they have what they call an arc plug, which is a lightning arrestor fuse that comes out of there. So let's take these things apart quickly and take a look at what they look like inside and see what the differences are between the cheaper Daiwa and the more expensive Alpha Delta. I have a 4-port. This is a 4-port AD, so it's a little more pricey because of the 4 ports. I think this was about $130, $140. I don't remember. I bought it from, I don't know, HRO or RNL or somebody. Gigaparts, I don't know. And then there's also a 2-port Alpha Delta, which is cheaper, and the 2-port Alpha Delta is $85. This Daiwa was $45-ish. So inside, and you can see here, there's not much to this. If we look close, here's our selector switch, and it's in the common position right now. Whoops. It's in the common position. And how this works is, as I rotate the switch, it brings up the metal tab for a specific connector, right, to this, and makes the connection to the common by forcing that up. So that's like a nylon bushing, and it raises that metal tab up to this bridge piece here, this guy right here, and forces that metal arm up to the bridge, and the bridge is soldered to the center pin connector on the common port. So that's how it makes that connection. When we switch it off of that, of course, that one drops and it raises the next one. There's a little play in this without the backside on, because there's a little bit of spring tension holding this together. And without the spring tension, it gets a little wobbly. And then there's our common position. And when we're at our common position, of course, it's not pushing up any of those metal pieces, so there's no connection anywhere. And you can see in the back there, they're not, angle's hard to see, but they're not touching any of those. So when we're in that center position, everything's off. The ground, the shield of the SOs is connected to the case. So that's why it would be super important to fasten this to your shack ground. Otherwise, the only ground you have is this box, and that's not much of a ground. So that's it inside this guy. There's, it's fairly simple. There's not a whole lot to it. And let's take a look at the Daiwa. And similar to the Alpha, there's a few screws in the back we have to pop off. The ground is a little different here. It has that little tab. But that's really the only difference on the back side. I actually think I like that little flippy tab a little better. Because when you put these things in your shack, with these models, typically they're going to get screwed to the wall or something. Ooh, let's watch Jim try to work a screwdriver. Okay, come on. How hard can that be? Come out of there. All right, there we go. Woo, we made it. I'm smarter than a box. So here's the inside of the Daiwa, and it works a little differently. It's a different kind of setup. So we're on the left connector here. Of course, that's this one when I turn it over. And so our knob is pointing to this way. But what that does is causes this pivot arm to counter-rotate down here, and that pushes the center pin of the other connector to ground, in this case, to the frame of this device. So that's how it switches between them. When I move over here, it lets that one come in contact with that gold block right there, which is connected here to the center pin. So they're both essentially the same inside. Now this does not have, obviously, the lightning protection, and it doesn't have a detent in the middle like the Alpha Delta does, but it will sit in the middle just fine, and it's not going to, there's not a lot of wiggle room there. You can feel when it starts to touch. I don't know that I would trust that, but that is exactly the same thing the Alpha Delta is doing. It's just that there's no clicky position there. That is exactly the same thing. So honestly, other than a slightly different mechanism, I don't see a nickel's worth of difference between the insides of these two, because with this guy in the center, he's connected to both of the center pins, and they're not connected to any center pin back here at all. And since they're touching this block here, he's connected to the frame of this device, so they're pretty much straight to ground as well. All right. Let's go take a look at this on, we're going to hook up our meter here, and we'll take a look at the insides of this thing on the continuity meter. All right, I've got our meter. I'm using a Pros Kit MT5211. This is the one that Electro Boom uses. So this must be the truth meter. Just a second. And what we want to do is we want to see what this looks like when these things are, we want to test continuity, right? So we should have connection between all three shields, and we do, and that is what I would expect to happen, and that doesn't change because the shield on the connector is connected to the case. What will change on these is the center pin. So when I test the input, that's connected, this one's not. Swap it over. And when I have it in that center position, even though it's not an official thing, there's no connection between the center pins. All right, let's take a quick look at the Alpha Delta. Same deal. On this guy, I've got him, he's in the center position at this time. But again, obviously, because they're all connected to the shield, or to the case. Now, this is our common port right here in the center. So that's your input, for example. And I've got the switch going to this port. So those two are connected. That's not. That's not. That's not. So it makes perfect sense. We could pop this thing out. And take a look at it, and that's it. There it is. So that is the, that is the arc plug. And I haven't studied on these. I'm sure that has a rating. This is some sort of gas thing, and I don't believe that has a polarity, and that just goes down in there like that, and then you put this brass screw in there and screw him down, and he makes the connection, I assume, between the hot wires, the center pins on the connectors. Right? Since the case is all tied together, it has to be on the center pin. But that's it. So there's our two coax switches and what they look like outside and inside. As you can see, there are some differences. And we're going to go put these on the VNA now. I'm going to hook them up to a Libre VNA, and we're going to take a look at SWR and insertion loss or isolation. It's the same thing in our case. We're trying to see how much isolation, how much insertion loss is here between the active connection and the connection that we're not using. So join me inside and let's put these on the meter. Okay, so what I've done here is I've pulled up DX Engineering, and I just grabbed their website because it was the first one I thought of. It doesn't really matter what website you look for or where you buy a coax switch from. The gravy is in the specs on these switches, and I just wanted to pop out some different examples of coax switches for us here. So here's an alpha delta. Let's pull this one up. This is the first one that came up. I typed in coax switches. We got 247 results. This one is $83. This is a 2-port switch. As you can see, this has the arc plug connection available in it, as well as the common port. If we go down and take a look at the specs on this thing, we can see that obviously it's a 2-port. It's an SO239 connector, 50 ohm impedance, insertion loss of less than 0.1 dB, isolation, and this is what we're going to test, more than 50 dB of isolation between those ports. So that's awesome. This particular switch is rated for 1500 watts PEP, 1500 watts CW, key down. So this thing it's a tank. It's a hoss. It's rated through 500 megahertz, 0.1 dB of loss up to 30, and then less than 0.5 dB through 450 megahertz. So this switch is perfectly acceptable SWR-wise as well as isolation-wise, all the way up through the 70 centimeter band. Most people are going to use these for HF, I feel. That's what I use mine for. So I'm only really today when we put it on the scope, we're only going to take a look at the 160 band down to around 11 meters, 30 megahertz, the HF band. So this is a replaceable part. This is their lightning arrestor piece. They call this an arc plug that goes in that little hole right there. And that's a feature that alpha delta switches have that a lot of other switches do not have. Here is the other switch that I have, the Daiwa 201A. You can see the difference in price, $37 versus $83. So 2-port switch to 2-port switch price comparison is half the price. So let's take a look at the specs on this guy. And on this one, you'll notice it doesn't have the arc plug. So there is no lightning protection on this switch. There is no common ground port on this switch, as we've already discovered when we opened them up and looked at them earlier. But what does it have for isolation? What is it telling us? Well, their specs, blah, 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 50 ohm impedance, all ports grounded position. I don't know what that means exactly, because I assume it means when I switch to the other one, it grounds out the unused ports. There's not a common ground. Whoa, the power rating on this guy, 2,500 watts peak envelope power or 1,000 watts CW. So not full legal on CW. You might want to buy a higher rated switch if you're going to be using CW at full power, but 2,500 watts PEP ain't bad. And listen, I have a 100 watt radio. I am likely to only ever have a 100 watt radio here in my shack, out in my shop. I'm not going to get an amplifier. I'm not going to. So something like this is perfectly fine for any purposes I'm going to have. The power rating that it's listed that it can handle, as well as the isolation between the two. Now, I haven't seen isolation listed yet. Let's see if it's down here. Frequency range, this says up to 600 megahertz. There's our power again. SWR 1.12 across the range that it's listed at, which is 0 to 600. Insertion loss, less than 0.2 dB. The alpha delta said less than 0.1, but we're talking 0.1 dB. And an isolation of 60 dB up through 600 megahertz. So that ain't bad. That is not bad. And again, we're going to put both of these on the VNA here in a minute and take a look at those numbers. And this is an SO239 connector model. Okay, so we've got our calibration all finished. So what we're doing now is we're doing a measurement on S11 and S21. And so I've got this set up, and the way this is set up is the VNA is going out of port 1 into the single port input side of this switch. On the left side of this switch, we have a 50 ohm termination, and on the right side of this switch, we're going out to the VNA for the through measurements. Okay. So if you look at the screen, what you see up here is we're connected right now. This is our SWR measurement here on top. And as you can see, the scale, it's 1. I mean, it might be 1.01 or something, but it's 1. And I've got this set on the HF range. So we're running from 1.5 to 30 megahertz. That's all we're looking at on this particular setup. And then in the bottom window, you can see our isolation, and it's 0. There is no isolation because we're connected to that port. And again, we have our calibration complete, and this is the test we're going to make. So if I switch the switch out, what you're going to see is the S11 on top is going to go basically infinite, and S21 is going to drop, and that is our isolation. So let me switch it over. And as you'll see, our SWR did not scale. Why for is that? Because I have a 50 ohm load, that's why. Okay. That makes sense, actually. Had kind of a brain seizure there. And it auto scaled, and I changed it to auto scaling here. You can see we're at 1.10. This is down at 1.5 megahertz up to 30. So this is still essentially flat SWR. The difference between 1.09 and 1.10, 1/100th of a point. But what is interesting is that our isolation changed completely. So now when we're over on this side, what this graph is showing us here on the bottom is the amount of signal that's coming through on the right side of the switch where our VNA is connected. All right. And we're down at minus 70, below minus 70 dB. Let's see, minus 77 down here at the 160 meter end. And up here at the 10 meter end, we're minus 67 dB of isolation. So what that's showing me is I can absolutely put a radio on here, and this thing will completely isolate the signal. It is 67 to 77 dB down. So we're on common right now. You can see it labeled there. And again, we have the same kind of thing. We have, let me put this on port 4, and we'll do it to simulate the way we did it with the other one. So this is grounded. Now this is the difference, one of the main differences between this switch and the alpha delta is common is straight to ground. There are no antennas connected. As I showed you when we tore these apart, this switch does not have a ground position per se. You can kind of jiggle the switch in the middle, but it's not designed to do that. On the alpha delta, you have a straight up common port, which takes everything to ground. So let's go to port 3. And as you can see, this gives us outstanding SWR because we're connected through, right? We have no isolation. Let me move the mouse. I'm pointing at the screen and you can't see me pointing. We have 0 isolation at this point. And our SWR, again, from 1.5 meg to 30 meg, is showing us that it's essentially flat. I mean, it starts here at 1.06 and rises to 1.13, and you see the little drop and gradual rise back up. But out here at 10 meter range, it's 1.03. So that's flat. The auto scaling makes it look large. If I didn't have auto scaling on, you'd see a flat line. And we look at our isolation line because we're connected to port 3 right now. We have 0 isolation. That's the line we're connected on. So if we swap over to port 4, our SWR is essentially, again, 1 because we're on a 50 ohm load. But the isolation we have is down here at the 160 meter end, minus 78 dB. and at 30 megahertz up in the 10-meter area, 11-meter band, it's minus 64 dB. So what does this show us? Well, it does the same exact thing as the cheap switch. It does the same exact thing and within a few dB of the cheap switch. And if you roll this video back a few minutes, you'll see that actually the cheap switch had a little more isolation than the Alpha Delta did. Now, as I pointed out earlier, the Alpha Delta has a couple of features that this guy doesn't have, but I'm looking at the numbers here on the truth detector, and it tells me that for what I'm going to use this for, it makes no stinking difference. You know, I originally bought this when I had two radios. Here in the shack, I had a 7300 and a 991A. And, you know, looking at the specs, I said, okay, this will work fine. 100 watts, you know, is pause here and edit that. So 100 watts is, let me start over, edit from here, go. 100 watts is 50 dBm, and we are minus 70 plus down on this switch and the same on the other switch. So 50 dBm minus to minus 70 means that at best we're up at minus 20 dBm of output power bleeding through either one of these switches. And according to sources I've read in various places, most radios can easily take 20 dBm of power back in through the antenna port. So, you know, choke where appropriate, make sure you have a dummy load, use a good switch. But I don't see a whole lot of difference between these two, short of the features we've talked about. Guys, I hope you enjoyed that. That was a quick little comparison between a couple of specific manual coax switches. And as you saw, the specs pretty much matched what we saw on the VNA. In fact, the VNA gave us better results than the published specifications. Give me a thumbs up if you enjoyed it. Please subscribe to the channel if you're not. And I look forward to talking to you again. Make sure you stick around and enjoy the rest of the YouTubers Hamfest 73s.